So we're now moving on to two more projects before the break. This is project 63. It's Henrik Nordling. And Henrik is going to talk about beating 6 hours, an attempt to extend the lifespan of the organ transplant viability window. So when an organ is taken outside the body, there is a certain length of time that it can continue to live before it is used in another human to help them survive. So Henrik is at the Athénée de Luxembourg. He is 17 years old, and we can go to him now.
I'm seeing, so your project consists in making organs more viable for a longer time before transplant, is that right?
Yeah, so when you're transplanting organs, you remove it from the body, the donor body, and you only have a certain period of time where the organ is viable for transplant. And in the case of hearts, it's between 4 and 6 hours. What I want to do is I want to develop a system that extends that period of time. So instead of having 4 to 6 hours to get a heart from a donor to the recipient, you have maybe 18. So then you could maybe do a transatlantic donation, or you have just a longer period of time so that pressure is reduced. And the thinking is the body is a machine, a little bit more temperamental than, say, an engine, but it is a machine. And we understand how it works, we understand the processes. And so if you just break it down step by step, then you can understand what the heart wants, what it does and what it needs. And you can, when it's removed from the body, you understand what you need to substitute. So the heart beats, it has a pacemaker. Internal pacemaker doesn't receive a signal from the brain. Well, when it's removed from the body, you have an artificial pacemaker to keep it beating so that the cells are still functioning. The heart is a pump, so it pushes fluids through, it pushes nutrients through. Now there are 3 different types of blood vessels in the heart. You have the pulmonary arteries, the coronary arteries, which is what's important because the coronary arteries are the blood vessels that supply the heart with its own nutrients. Now the heart isn't pumping, so it is pumping because of the pacemaker, but we're also supporting it with a ventricular assist device. Now this is already used in heart surgery, and we're using that to help the heart pump the fluid solution, which I'll explain a little bit, through the coronary arteries to keep the heart supplied with oxygen and nutrients. The key element of this is the nutrient solution. Because it's a living organism, it's a cell. It needs oxygen, it needs nutrients, it needs waste products to be removed. So the nutrient solution, I've based it off of Ringer's lactate solution, which is developed to have the same tonicity as human blood, roughly. And I've also boosted it with some fatty acids, some ketones, some lactates, and some amino acids so that the cellular function can resume, so that it has all necessary ingredients to keep functioning.
Well, you explained everything. I think I have no more questions left for you. Seems like very detailed work. Good luck to the juries. Thank you.
All right, one more up in the air. Thank you very much. Thank you.